Identifying a material from its resistivity. Objectives: to determine the resistivity of a material wire. Safety of this experiment: do not measure current for zero length. This will send a damaging current through the ammeter. Apparatus: power supply. We adjust it to 4 volt to decrease the current. Nichrome wire, variable resistor, ammeter, but I use digital ammeter and also digital voltmeter. Meter ruler, connecting wires, also crocodile clips. Instead of switch, we use the switch of the power supply. Micrometer screw gauge. We use the micrometer screw gauge to measure the diameter of the nichrome wire at 3 different places. So I stretch it. Then first of all, I adjust the zero, zero error. It is perfect. So I move it like this. The main scale is 0.5 and the vernier scale is 19. So the diameter of this of the wire at this position is 0.5 millimeter plus 0.19 millimeter. So the total is 0.69 millimeter. Another position, the main scale 0.5. The rotational scale or the vernier scale is 19. That is the same, 0.5 millimeter plus 0.19. So the total in this position of the wire is 0.69 millimeter. A third position, the main scale is 0.5. The rotational scale is 19. So the total is 0.69 millimeter. Then the average diameter of the nichrome wire is 0.69 millimeter. We convert diameter from millimeter to meter. So from millimeter to meter, we multiply by 10 power negative 3. The radius equals half the diameter. So the radius equals this value. From the radius, we can calculate the cross-section area by r squared. So this is the area, cross-section area in meter squared. I stretch the wire on a wooden ruler like this. I divide this wood into parts. Each part is 10 centimeter by using the ruler. So it's here. So the first length is 10 centimeter. The second length also 10 centimeter. The third length 10 centimeter, and so on. We set up the circuit as shown in the figure. From the power supply, positive terminal of power supply, to the ammeter. And from the ammeter, I use the crocodile clip. From the ammeter to the wire. From the wire to the rheostat. I will measure the current, so does not affect it to put the other crocodile at any position of the wire. No problem at the end here. From the wire to the rheostat. Finally, from the rheostat to the power supply. This connection is series connection. Switch on the current, switch on the power supply. I check here the rheostat. Yes. So it's okay. Now I connect the voltmeter to measure the resistance of different length of the wire. So switch off. The first one, we have here junction. Join the ammeter to the voltmeter. And then from the voltmeter by using a crocodile clip to the first 10 centimeter. So this distance is 10 centimeter. We check the connection. It's okay. I adjust the ammeter to give us, okay, here, the ammeter. The current here in the circuit is 0.4. Now this current will be fixed. No change of the current. So the current through the circuit is 0.04. I will take the measure of the voltmeter through 10 centimeter length of the wire. It's on. So the voltmeter here is 0.2. 0.02. So this is the voltage. The current is 0.04 and the voltage is 0.02. I increase the distance 10 centimeter more. So now the distance is 20 centimeter. I take the reading of voltmeter. I take the reading of the voltmeter. It's here. It is 0.03. So the current is 0.04. So the first length it was 10 centimeter. The second length 20 centimeter. We know that the voltage increases. Now I change the distance to be 30 centimeter. So now the distance of the wire or the length of the wire now is 30 centimeter. Switch on the current. The voltage is 0.04. So 0.04 when the distance is 30 centimeter. When the length of the wire is 30 centimeter, the voltage is 0.04. More distance, more length. So now it will be here exactly 40 centimeter, the length of the wire. So we write here 40 centimeter. Of course, 0.04, this is the current for all. Now I take the reading of the voltmeter. Switch on the current. It is 0.06. Switch off. The last reading when the length of the wire is 50 centimeter. Switch on. The voltage is 0.07 when it's 50 centimeter length. So that are the readings. The results of the experiment when the length is 10 centimeter, the voltage is 0.02 and so on. But because the current is the same, so the current is 0.04. We use Ohm's law to calculate the resistance in each length of the wire. So we divide V by R. So we divide 0.2 by 0.04. Divide 0.03 by 0.04. Divide 0.04, divide by 0.4, and so on, to get the resistance of each part of the wire. So when the length is 10 centimeter, the resistance is 0.5. When the length is 20 centimeter, its resistance is 0.75 and so on. Calculations and analysis. We know that R, the resistance equals rho L over A, where rho is the resistivity, L is the length in meter, A is the cross-section area. Then we can rewrite as R equals rho over AL. Rho is constant for the wire, and the cross-section area also is constant. Then the resistance proportional directly to the length. If we draw the relation between the resistance and the length in meter, we will get a straight line passed through the origin. Its slope equals rho over L. If we need to calculate rho, then we find the slope and multiply it by the cross-section area. We draw the graph as shown. The length in meter, so it is 0.1, 0.2, 0.3, 0.4, and the resistance in ohm, we divide it into 0.25 each unit. We plot the points and we draw the best fit line. That best fit line, it is a line in between most of the points. We find the slope by drawing the triangle. So we find that the slope equals 3.75 ohm meter. So the resistivity equals A, cross-section area, multiply the slope. This is the slope, and the cross-section area before we found it was 3.74 times 10 power negative 7. The answer is 1.4 times 10 power negative 6 ohm meter. From the internet, the range of resistivity of nichrome wire is from 1.10 times 10 power negative 6 ohm meter to 1.5 times 10 power negative 6 ohm meter. Then we know that our value is in the range of nichrome wire. The sources of error in this experiment is just the best fit line because I used digital voltmeter and digital ammeter. Also, I reduced the number of wires in the circuit to get the value of resistivity in the range of the correct value. I hope you understand this experiment. Thank you.